Hello everyone, this is a video lecture for Precalculus section 8.4 Parametric. Parametric. Um, Parametric is basically involving t. So we're going to be seeing x in terms of t, y in terms of t. If you go and start graphing in your calculator, it'll be x, it'll be x in terms of t, y in terms of t. T is your independent variable, and x and y are dependent. Both are dependent on that. Compare and contrast to something like this guy. This is your independent variable. This is dependent variable. So now I'm saying that both x and y are dependent on blah, 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 t. They both have a t in common, or whatever. Okay? If that doesn't make a lot of sense, we're just going to start doing some math here. 84016. X is equal to tangent t, and y is equal to secant of t, and they want to keep t between negative pi over 2 and pi over 2. And they want to eliminate the parameter. Okay, so what does that mean? Basically, they say, t, you're going to go bye-bye, and I want to get y equals blah, blah, blah with x's in it. Okay? That's the idea. Can I get back to a regular thing that I know from what I have here? There's no special formulas for this. This is actually very simple. I'm going to take this guy, and I'm going to say that t is equal to the arctangent of x. How I did that is I inverted the tangent to the other side. However you want to think about it, arctan both sides, cancel, whatever. T is by itself. Now I'm going to take this one here and replace t with the arctan of x. And technically, in a way, didn't you just get your answer? Like y in terms of x, y in terms of x, cool. But I don't think it's going to accept that, honestly. So what we need to do is to simplify this a little bit. I see this here as an angle A. And so I have a triangle, my angle A. And notice that tangent is tangent of angle A is equal to x, which is technically x over 1. So opposite over adjacent. This leaves this guy here as 1 plus x squared for my hypotenuse. Now, they're wanting the secant of A, which, as you know, is the hypotenuse over the adjacent. And so then we get this square root thing here. So I've now got y equals the square root of 1 plus x squared. That might work. They're going to want to do a little bit more math. Square both sides, because of the domain restriction stuff. Square both sides. Y squared is now equal to just plain old 1 plus x squared here. Again, that might be enough. And if not, basically what they did is they moved the x squared over. So I got y squared minus x squared is equal to 1. And that's what they finally result in. Either way, though, I'm sure something along the way would just be fine. Next problem, 84011. I got x is equal to t squared. I've got y is equal to t to the 4 plus 4t squared minus 1. And they want to eliminate the parameter just like last time. Well, how I see it is I'm going to rewrite this y as t squared squared plus 4t squared minus 1. Notice that this square can be plugged in directly here as x squared plus 4 times x minus 1. And, well, we're done. X squared plus the 4x minus 1. Y equals, looks pretty, works out great. We have a parabola. 8.4.008. So I got x is equal to t squared. Y is equal to t to the 4 plus 3. Again, I see this as t squared squared plus 3. And I could just replace it directly with an x And, well, there you go. Now, this guy's a parabola, but apparently it's only 1/2 of a parabola because t is bounded by... Oh, yeah. Think about it like this. See how x is always positive? This is always positive. Why is that? Because it's a square. T could be a negative or a positive. It doesn't matter, but I'm going to always get a positive whenever I square it. Therefore, it's going to be restricted to 1/2 of a parabola, not, well, not the other way. Moving on. 8.4.014. I got x is equal to 4 cosine of t, and y is equal to 5 sine of t, and they want to go from 0 to 2 pi. That's understandable. I'm just going to tell you straight up that there are some of these that are formulaic, and this one in particular stands out to me greatly. This is actually a circle, or in this particular case, it's an ellipse. Ellipse because my radii are different, but if you had the same like 4 and 4, let's say, it would just be a plain old circle. There's also ways to find out the center. Here it's centered at 0, but you could also tell that this is going to be counterclockwise. And the reason why is because x is cosine and y is sine. That is typical. We've already known that x is cosine and y is sine. What does that mean? It means a unit circle. Notice we start from 0 and go around counterclockwise. If you had flipped them and x was a sine and y was a cosine, then it would have started up at the top, I think, and went down clockwise. That is not the case here. So if we were to graph this thing, I'm just saying that it would look something kind of like this here. Notice that we have a little bit more y than we have x. This goes up to 5, but it only goes out to 4. Okay? So there's your ellipse, and again, direction is kind of important for parametric functions. That's cool and all, but now what's the answer? Well, ellipses follow a certain format that looks like this. Now, this is going to be, again, in the next chapter. I'm just going to go ahead and tell you the formula. This is the formula for an ellipse. And I'm going to do it a whole different way whenever we get there. But for right now, what's associated with the x is the 4, and so I'm going to put simply a 4 squared down here. And what's associated with the y is a 5. You put a 5 squared down there. There's your answer. So I know that some of this is just like, wow, how did you pull out that answer? Well, you just got to know it. That's why you're listening to these video recordings. That's why it's like, a classroom experience. You just have to know that there's a formula, I guess you could say, for some of this. I'm sure there's another way to do this problem, but it would take far too long, and this is leading into the next chapter anyways, which is coming up soon. So be prepared for this, because that's what we're going to be doing. I'm teaching you ahead of time, I guess you could say. Eliminate the parameters, same thing here, because I don't understand what this is. What is it whenever you get y equals blah, blah, blah? Is there something else there? This is very similar to one another. What instead I'm going to do is say that x is equal to e to the t to the negative 1. And so notice that what I have is this is the same as that, and I plug this in now. X is equal to y to the negative 1. And if you want to rewrite it pretty, I guess, you would say that it's 1 over y. Now, this is cool. Y equals 1 over x. That's cool. Another version is xy equals 1. This is cool. I don't know which one they want. Probably all of them is fine. But this is the one that we're probably most familiar with. And what would that look like? Well, generally it looks like this guy here. The thing is, in particular, is that this is a parametric, so what direction is it going? Notice that my x is a negative e to the negative t. So this, for one, is always positive. So we're not going to have anything down here. Well, because it's on the other side, we're not going to have anything over here at all. The more my t is, the smaller my x is. The more my t is, the bigger my y is. So y is getting bigger, my x is getting smaller, going this direction. Okay? Super cool. Next question. 84031. I have a line with a slope of 1/2 and a starting point at 6, negative 4. They want it in the format of x, t, y, t, which I had mentioned to you earlier, is equal to, and then they basically force us to do this. Cool. Well, when I see line, I see y minus y1 is equal to m times x minus x1, just like that. We have our m, I have an x1, I have a y1. Here we go. Y minus a negative 4 is equal to 1/2 x minus 6. I'm going to simplify it a tiny bit, of course. So we got y plus the 4, 1/2 x minus 3, move the 4 over, y is equal to 1/2 x, and then minus 7. So this is pretty cool, but that's not what they're finally wanting. Remember that they want x in terms of t and y in terms of t. So how do I split this back up into x equals blah, 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 y equals blah, blah, blah with t's in it? How do I do that? Well, I'm going to tell you it's very simple, but don't overthink it. I don't care what WebAssign says. I know this will work. Are you ready? I simply say, well, x is t, and therefore this guy, I just put a t in, and it works. The end. That's your answer. Like in the parentheses, you put t, and then 1/2 t minus the 7, just like this. That's your answer that you would type in. Now that's cheating. It's not really cheating, but it's basically a cheater answer, cheater style answer, I guess you can say. I just set x equal to t. I say x equals t. Why did I set x equal to t? Because it's easy. And it makes it really simple. Just a thought. Don't overcomplicate it. It's a classic way to answer that problem. I don't care what they're going to have. They're not going to have this. I don't care what WebAssign has. It's not going to be that. They're going to do whatever they want to do. This works. And it should work. I'm going to say 99% sure. I'm sure it's working. If it doesn't work, you tell me. But I'm sure it works. So this one's kind of interesting. It's a word problem about something hitting the ground. How fast is it going, all that kind of stuff. This is V naught cosine of, that's an alpha. Looks kind of like a little fish. All times t. Now, I get confused with this format. We're saying that it's cosine of alpha, and then times this guy, and all this times t. Okay, this is like just one big number times t. Okay, like 5t, something kind of like that. I don't know what it's going to end up being, but we'll see here. My y is equal to v naught sine alpha t minus 16t squared. Let's explain this. Again, the same with the alpha here. This sine and cosine of the v naught is my initial. I'm going to write initial. And my initial speed, my initial velocity for the object. So it's going in some speed in the x direction and y direction. Notice it's positive. So it was like thrown up in the air kind of thing. What I imagine is something kind of like this with my initial angle here, right about here, being my alpha. Okay. And then it's going to come back down. So why is it coming back down right here? This is my gravity. Okay, awesome. Blah, blah, blah. We got our formulas. Cool. Now let's actually use them. They say that V naught is equal to 1984 feet per second. Now, I don't know how fast that is, but to me it's pretty fast. Alpha is equal to 30 degrees. So they're in degree mode. That's kind of nice. If they're in degree mode, you need to change your calculator over to degree mode. Okay. Part A, it says, how many seconds until it hits the ground? So, how long to hit the ground? So, think about it. Again, this is a projectile. It's doing something kind of like this. And so, how long did it take to get over here? Let's see. Hold on one second. So, how long to hit the ground? So, I'm going to think that y is equal to 0 here. And so that's exactly what I'm going to do. I'm going to take this formula right here and say y equals 0, and here we go. So 0 is equal to, my v naught was the 1984 sine of 30 degrees times t minus 16t squared. And so I need to solve for t. I'm going to factor a t out. I mean, I could do that at least. Leave it behind a 1984 sine of 30 degrees minus 16t. And this is still equal to 0, so I factored a t out to the front, like right here, I guess. That looked ugly. And so I could solve for t by saying, oh, well, t equals 0. Of course it does. Right there, that's 0. And then I could solve over here as well. Notice that if I move that t over and divide by 2, or I'm sorry, divide by the 16, then I've got 1984 sine of the 30 divided by the 16. Calculator, and I actually get 62 seconds. Like straight up 62. Okay. Cool. Now what? Part B now says, well, how far did it go? What they're asking for is x. Now, x, whenever I have this many seconds occur. If you go back up to the x formula, I'm just going to plug that t in and, well, everything else. So I got the 1980, this is by x, 1984 cosine of the 30 degrees, and then times my 62 seconds. Well, when you put all this together in the calculator, I got 106,528.0529 feet. The thing is that they don't want feet, they want blank miles. So how are we going to convert it? Remember that I'm going to divide this number by 5280. That's the conversion. Have you memorized that number yet? You should. 5280. And I got 20.1756767 miles. Okay, so that's good. Part C says, what was the max height? On this particular problem, and it's super easy this way, this is what's going on, and this is at 62 seconds. The max height is right here at 31 seconds. Okay? So 31 seconds should be the max height. Again, height means y equals something or other. That's what we're trying to find is y. Well, I'm going to plug this into the formula again. 1984 sine of the 30 times now 31 minus, and then that 1631 squared. And so I've got 15376 feet. Now, again, they don't want feet, so I'm going to divide it by the 5280, and I got 2.912 miles. I mean, this must be like a rocket or something, or I don't know. Big projectile. Last question, 84040. I have an x is equal to sine of t, 6t, and I've got a y is equal to cosine of 4t, and they want to graph it. Just make sure to put this into parametric mode in your calculator. But what does it look like? Well, it kind of does this and whatever. It's not exactly a sine or a cosine function, but that's the idea. Just use your calculator to do it. Parametric mode, you type it all in. Make sure you're also in radian mode for this one. I was just remembering that. Radian mode. And it should be fine. Just, there you go. Something kind of like that. That's all I have. That's the end of Chapter 8. Whew. All right. Thank you very much. Have a great day.